a talk this morning about the zero waste as a director of the zero waste. Actually, he is also a director of this Uniflow Power Singapore. So he will be talking about this combined heat energy unit using biomass today. Mr. Ong, please.
Okay, thank you very much. Right, this item, let me see now. I get the share screen. All right. What I like to do, okay, this is my, here, my presentation. This is the latest version of what we have now. And what I like to do is actually to quickly show you a video. Let me see if I can you all see the video?
Not yet.
Oh, okay, I have to share. Hang on a second. Let me reduce this and take away. Find the video is actually something. Hang on. Share. Oops, I lost it somewhere. Where have everybody gone to? So there we lost it. Okay, hang on, let me check the advanced setting here.
Yeah, take your time.
So shut down this screen. Can you see this?
Not yet.
Oh, still not
Maybe,
working.
yeah.
Go back to
You may need to share your whole computer screen if you have a
I have
different
a stop, I have a stop share.
Yeah, then share another
share
screen.
Again, share again. That would be this one.
Okay, video.
Yeah,
You can see it?
Yeah, but no
Yeah,
sound. Maybe you need to click the sharing sound.
You can't hear anything?
No.
No.
Well, actually the sound, I will play the sound. Hang on a second.
I think the sharing part, you need to tick the box, sharing sound.
Oh, it doesn't happen.
I mean, when you start the sharing.
Okay, sorry, with the low volume. Hope I don't deafen myself. Is that okay? Anyway, it doesn't matter because it's only a musical background.
Okay.
Right. So, okay, let's start from the beginning. This machine, where the Australians call it the Cobber, and Cobber is actually an Australian slang for friend. So it's a very simple machine, but this was a few years ago, so we're advanced in. So you can burn anything organic, even logs as big as an arm. We have done it with cow dung, and that's what cow dung looks like. We have done it with sawdust. So red hot coals, even rice husks, coconut, bagasse, firewood, of course, which is almost everywhere in the world. This is the machine. This is the engine. I'll show you a better photograph. This is the alternator. Well, this is the engine that's insulated now. Flywheel, which converts the mechanical to electrical energy. It looks very simple, and actually that's what it's intended to. We're getting about 4.5 to 5 kilowatts. Condenser produces hot air, and this is the steam. All right. Now this is, okay, I'll stop this. Okay, now I go back to my article. Okay, here we are. All right. So let's okay. In this case, now we'll start. This machine is quite small. It is now less than 2 meters. 2 meters height, 0.9 meters width. So it's actually the size of a double fridge. Here we have a machine that is very unique in the world. All right. The unusual thing about this is that it has no electrical parts, no electronics at all, except for the alternator, obviously, because that's needed to convert mechanical to electrical energy. Okay. So we are basically, and we means Uniflow is the Australian biomass and energy company. And this is our invention, for which we call it the Cobber. And we have offices in Australia, Singapore, and India. So what we have done now is that from quite a few years, we have made this into a machine. So from really simple drawings. So this one is a demonstrated technology. We are able to convert low value materials into available energy resources, electricity, steam, heat, mechanical power, and therefore we can reduce fossil fuels. At the same time, we are working on partnerships in India and Singapore, and quite frankly, also in ASEAN. So what we are saying now is this is a small scale, this is a micro scale really, but it's an advanced combined heat and power generator for modern homes and communities using locally generated biomass materials, transforming into useful energy. By using local biomass, we actually skip a lot of the cost involved in bringing in materials from everywhere else. Okay, so this is the technology by itself. It's not. All right, so the quick one is we have a board of directors, Sylvia, John Matheson, and Michael McCain. I say that it's probably good that we are all engineers except for John, who's a banker. The people directly involved are Michael McCain, Paul Stewart, myself in Singapore. Since then, we have actually increased our manpower. This is Rosie Barnes. She has a PhD in something else quite amazing. She runs her own YouTube channel called Engineering with Rosie. Quite interesting because she's a new technology development manager and quite good, quite frankly, in complex multidisciplinary systems. Hadley is on our side, is also a very good project manager, hands-on. He's actually commissioning our machine right now in Canberra. Along the way, we are now doing, or have done recently, several reports. Australian agriculture study, okay, greenhouse energy balance, which I'll show later. This is by our Cobber versus diesel and the mains electricity. Insight into the use of the Cobber in disaster recovery. And actually, disaster recovery will be a very interesting potential market for us, because one of the things about disaster recovery is that when it happens, you're almost always going to need energy. It's no point, asking for help, but then your doctors go down there, all right? And there's no energy, no hot water, no steam. I myself have just recently completed an ASEAN market and policy review because Singapore is the regional office. So going back to this greenhouse, this is actually a part of the study we just completed. So it covers the calculations on use of petrol, diesel, electricity, and so forth. Okay, so we are actually using globally recognized greenhouse emission benchmark, and not just for measuring how much CO2 is reduced. We go beyond, so that means everything, NOx, methane, and everything else. So we've found if we're just making electricity only, and using firewood, we have a CO2 emission intensity 90% less than a small diesel generator and more than 95% less than a small petrol generator per kilowatt of electricity produced. Okay, and diesel is actually a very expensive form of energy in terms of dollars per kilowatt also. But you know, many parts of the world use diesel because it's the only alternative. In the combined heat and power, the Cobber produces just 4% of the greenhouse emissions compared to using electricity. All right. So for every kilo, that's only 40 grams. So that's very, very significant savings. This is done by Graham Anderson, I think well recognized and an expert, and have worked in Europe on many of these GHG inventory reviews. Okay, so we also have a office workshop in India too. So this is Aman. We are preparing to send back some units back from India. The reason is because, you know, we had some units fabricated, and with COVID, there's no point for us to go there, so we need to finish up the rest. This is a photo that you will most likely not, we don't actually show people most of the time. This is the machine itself without the skin. The boiler is inside here. I'll give you a quick glance later, but almost always it's hidden. The boiler is here, the fuel is fed to here, and then this is what we call an external combustion machine. So the fire and the power is generated here. Okay, then through pipes it goes through our machine to our engine, and it's here. This is our engine. It doesn't look like a normal engine, but it's a steam engine. Okay, then from here we the power is converted to mechanical power to this crankcase onto this flywheel, which you saw in the video. So from the flywheel to the alternator, we have actually got a simple belt. So very simple. And of course, from here, it gets to be converted to electricity, 240 volts, 4.5 to 5 kilowatts. The 4.5 kilowatts is actually average. It's not even maximum, it's actually our average. And in fact, in many of our instances, we have actually run it to 5.5, or even 6 kilowatts, but we are conservative. This is a safety aspect, but there's a pressure relief valve, so in case people are wondering. We do have air filters in case somebody is asking about emissions. It's inside here, so this is obviously filtering off the particulates, which is not so bad actually. It's pretty good. All right. Okay. For Singapore, we are fundamentally in the center of ASEAN or close to it. All right. We are quite well established here. We want to use Singapore as the regional hub for logistics and distribution into Southeast Asia. Okay. One of our aims is to actually manufacture in India and use Singapore to distribute out. And ASEAN makes sense because it is 10 countries with 25,000 islands, and many of these islands are run on diesel. They do not have main, electricity. Than 650 million people. But of course, India, because India has 1 billion of people. In fact, the electricity you need in India is far more than all of ASEAN combined together. Okay, so let us look at this. This problem. What is a problem statement? Is fossil fuels. Okay, many grids will use fossil fuel in one sense, one way or the other, and the grid itself, of course, does not reach every corner of a country. Well, in most third world countries, simply because it could be very expensive to go and pull the cables, all the way there. In one sense, if you're only a village of 500 people, governments may not have the money to bother with you because you're only 500 people or 500 voters. You are not 50,000. Okay, so the 9 to 11 million diesel sets or so every year, and even power grid solar farms, they actually have a form of diesel standing by somewhere in case obviously it doesn't have enough sun. All right, so diesel is fundamentally important in many of these countries, and really electricity can often be unavailable, unreliable. So for us, we are using woody biomass, as a common fuel, which is everywhere. Some people, of course, mentioned gasifiers, but gasifiers need to have very consistent fuel, so they cannot take variations in fuel, and it's also limitation in the number of settings. So the issue here is, if you are a village, then you're most likely going to get diesel in drums, most likely the oldest drum they have, because it's a one-way street. And if you are using a genset or to charge other batteries, eventually you have this problem of old batteries, very big batteries. And of course, with batteries, there are people in third world recycling this. It's a health hazard, among other things. So we have to look at this, that, batteries, are they part of the problem or the solution? Okay, so we do it by eliminating the battery. We have no batteries at all to start the machine. This is another more of a man-made problem. We have garbage mountains, it's ever growing. In this region, we have people burning palm oil simply because there's so much of this around the world, and they can't burn it fast enough. In many parts also, we have old palm trees. Palm trees after 20, 25, 30 years, they become less productive. The other point, actually, most people don't know, but it's like this at the bottom. They grow too tall to be harvested, so therefore you cut them down. And also there is forest clearing. Okay, so now our value solution is a small scale machine versus big machines. All right, so this fundamentally is a decentralized mini power station. It is fuel agnostic. As long as it is organic, it's our fuel. All right, and it has such design that it can be operated by the farmer. Not only by the farmer, I expect that it will eventually be run by the farmer's wife, son and daughter. That eliminates the need to have very complex mechanical electrical systems and backup. So for us, we are now at advanced beta prototype at technology realization level 8, which is almost to completion to 9. We are field testing it. Okay, so for us, we have this under our name. We are not an OEM, we are the originator, we are the inventors. So we have to be very careful that what we're doing works 100%. And biomass is everywhere. Okay, this becomes an on-demand renewable energy via direct combustion of free local fuel. And we can use all sorts. And from there, we'll get electricity, heating, hot water, and rotary mechanical power. Of course, we can also use fuel pellets. Okay, so our premise is very simple. We make energy where the fuel and demand is, instead of making it somewhere else, and then trying to cable it out far away. If you can light a fire with a cobber, you will be able to make power. Now, we don't have a battery, so as long as you can light a fire, you know how to light a barbecue fire, it's how it works. It's very simple. Any kind of organic material is a fuel, from sawdust, bagasse, construction wood, also kitchen waste, animal waste. Okay, so in terms of more technical bits, this is a bit 4.5 kilowatts of electrical, 20 kilowatts of thermal. Okay, so this is a single engine. You can't see that it's here, but it's double acting. It's completely mechanical control. There are no electronics or electrical or batteries required to start it. Okay. The boiler itself, which is this one, is quite small. It only holds 20 liters of water, and it doesn't need to be pure water. In fact, the one in India, we actually used sand filtered water. But at the same time, because of its design, we actually are able to have 20 bar 400C. Okay, and fuel is there. Okay, so we have two components patented. One is this engine, and the other one is the boiler. Okay, let's see now. Okay, so that's what it is. This is patented. It has no moving parts, but there are designs in its a structure that makes it very unique. So this is the machine now installed in Canberra for which we are commissioning. This is the lithium-ion battery for testing purposes. Those who want to see the video can actually log into our website here, or here is the video on YouTube. Okay, just a quick history of this. This is an early prototype, and as you can see, bare bones, and that's the machine where it is no cladding, no nothing. This is the machine actually that we had in India, in Bira, which is about 3 hours drive from Mumbai. At that time, we were working with Tata Power, who came to us. We built one, sent there, and we built another one there. So this is a machine. We got to this point, and now we are here. This is about the TRL7, for which we made many tests. So early part is innovation. We have IP, we have know-how, and we have applied research. So we have test bedding and industrial partnerships. Right now, obviously, we need to deploy this. Eventually, we hope to look for industry funding, market entry. Going on TRLs, we are pretty much here, systems validation. So if you look in this pictorial scheme here, just burn it, okay? We create the energy and you will get electricity. We'll get steam by itself. We'll get mechanical energy from the flywheel, which can be used to power other mechanical equipment like pumps. And there is hot water, which can be used for obviously, cleansing, for sterilization. These are all very useful and all are created from waste. In terms of Singapore, this is another one where we can actually turn our food waste into energy. From our point of view, unfortunately, this is not a priority from a company. So as we can see here, and we know that biomass, there's a lot of biomass and food waste. So we have organics and inorganics. They have to be separated, obviously. After that, because food waste generally has like 60-70% moisture, they need to be dewatered. Otherwise, the calorific value will go very low. And they can actually be made into pellets or cakes. Or for that matter, when it's dry enough, it can be mixed with cardboard paper, which is what, or pellet wood. Okay, so this one we transfer the linear practice of waste management, like take and throw into a circular method. Again, biodigesters, which is now what the government likes to push everybody to get, is limited to food waste and does not make energy. They do some dewatering itself, and they turn up and make a compost, or they claim to. The limitation here is that Asian food, or Singapore food for that matter, has a lot of oil, which is not very good, for many people for biodigesters, and it also has a lot of salt, which kills bacteria. So small-scale solar wind power have difficulty meeting community needs. All right, so it's obviously an up and down, and in many rural communities, electricity can be unreliable or not available. So what we had said is that there is no affordable off-the-shelf technology in the market for small-scale biomass fuel electricity production, let alone combined heat and power. Okay, just a quick one here. This is our biomass hybrid renewable system into pure renewable. Okay, so there is local biomass in many development communities and economies. It's there. Okay, so we can actually turn this into something of value, and it creates local jobs, local power, local products. Therefore, it keeps hard currency at home. Okay, so, and even the flywheel itself is very powerful. Actually, can be used to run fans, mixers, compressors. So this becomes a small enterprise energy platform. All right, so it's a mini platform that you can run almost like a micro industrial estate in the village. So this will be the power for innovation ecosystems of small communities. Okay, just a quick one here to update you. This is our demonstration site. We call READS, Renewable Energy Demonstration Site in Canberra, at the edge of Canberra. We have actually have a tender awarded to us for powering this heritage house, and it's going to be here, which I'll show you later. It's basically in the middle of, like, you know, a big field, as you can see. Okay, so this is the powerhouse with the doors open, and we'll see more. This is the back. We have a rainwater tank also. These are different views. So we have built the whole powerhouse. That includes plumbing to provide hot water and space heating, a 12 kilowatt-hour lithium-ion battery, IP camera, so that people can see it in operation anytime, for online and for data collection. Okay. Just another plan view of what we have. Again, and you know, unfortunately, or fortunately, we have many approvals. Okay, so as we go forward, we also are not just running the machine for running the machine. We have other development programs, and that will be the basis of our design and engineering center. ACT is just Canberra, Australia territory, Commonwealth territory. So while we are looking at that and mass production of the Cobber, we will have other projects to undertake. The purpose of mass production is very simple. Right now, the Cobber and many large energy machines are built, you know, almost one by one, or 5 or 10 at the same time. If we are able to produce this in a mass factory, say like a semiconductor company, then we could reduce the cost, not just by half. We can actually reduce the cost by 10 times. At the same time, we can also improve the quality, because semiconductor companies are obviously required to have very high quality finishing, but we obviously don't need that. So for us, it makes sense. Now, the Cobber itself, 90% is quite common structural items, but it's the rest of the 5–10% that our technology and our standards are there. Okay, so the other point that we want to be working at is that we are perfecting a number of energy apps, and the word apps is not electronic apps, it's actually applications that we can add on to the Cobber depending on the user. So that includes the design and testing, water desalination using waste heat, steam sterilization, all right, pressure cooker, waste materials, pelletizer, because there is a lot of biomass. It can be made into briquettes. So we can drive water pumps, mechanical lifts, threshers, and so forth. One of these things that is very important is aid development, because a lot of aid receives money. Countries receive aid, but it's a one-way street. So I think then we need to look at getting into this system where the aid is eventually going to be reduced. They have a machine that makes energy from all these waste materials. Okay, so what do we do in the meantime? So in Australia and in Singapore, and eventually in parts of ASEAN, we want to engage with corporates and institutes of higher learning, okay, to conduct applied research and development. Australia is going to be doing very fine research. We would look at applied research also to improve the process, data analytics, and systems optimization, different fuels and energy loads. So a compilation of system schematics, P&ID, startup procedures. So we're really writing that, several manuals altogether. This includes energy and engineering and optimization of energy offtakes. So we'll start from bench work to field running. We also need to coordinate with the field partners, because we need to get the feedback, and which is why we actually ran it for over a year or 2 years in India. Again, we would assist to set infrastructure for local test bedding in whichever country we are in. So this is about the last slide. So when we say apps, we actually physical applications. So steam, hot water, heat systems, they all come from the fact that we have a very good source of energy. So even sterilizers and so forth. We have found, for example, people donate, countries and governments donate, you know, in terms of disaster, but they can't get a machine there. Your diesel genset may be inside a warehouse, but if you have a flood or earthquake, it's not possible to get the machine to where it is. Whereas our machine is actually going to be in use by the farmer or the fisherman. Then he's the operator and he knows how to maintain it. Okay. Otherwise, you end up putting a small mini clinic there, but it's got no power. So the mechanical rotary power systems can be used for many rural activities. So again, we have food processing systems. So there are many ways as long as a good electricity. All right. So you can see from here, even dehusking. So we try to mechanize work that is available using very low fuel. And that's actually about the last of my slide. Yep, it is. Hang on a second. Yes, quite short, but I think we should get on to the Q&A if anybody has any questions.
Thank you, Mr. Ong. Yeah, as already we have the question in the Q&A box. Can you find that?
Yes, I just see 2 points. It is burning vegetable material, so not neutral from CO2 point. How can we reduce this? Okay, this is a very common question I'm glad came out. First of all, essentially, if it's organic, it is basically carbon neutral. All right. I know people might not agree, but it is carbon neutral by itself. What we have done is to actually turn this into a useful resource. In fact, in many places where you have agri waste, we tend to the farmers tend to burn. All right, and that's unfortunate because that's just the way they are. I've seen that in Philippines, in India, everywhere. So one is we are biomass by itself is fundamentally biomass, so we use that to convert into a useful machine. Useful purpose. Okay. Now the other one is that maintenance and support. This machine is quite unique because we have actually tried to do something very unusual, which is to actually simplify our invention or any invention, make it as simple as possible. Okay. Most designers tend to make things very complicated, and we try to go the other way around, make things simple, which is actually quite complicated to make it simple. This machine is totally mechanical. If you go back a few decades or even recently, in some parts of the world, you have previously cars, aeroplanes moving around, flying without any electronics or electrical. I'm quite sure that this one, you know, in the 40s, 50s, and 60s, they were all run on complex mechanical systems, no electronics. So we've gone back to let's make it simple, all right? And when you make it simple, who can maintain it? The farmer or the fisherman, because he for sure is not going to get a subcontractor. He can use his pliers, screwdrivers, and whatever, right? And there might be a village blacksmith. Of course, before we give it to them, we will have a training session for whoever is the local appointed people. We don't just say, oh, go use it. We have a training program of maintenance and so forth. There is essentially only one consumable, which is the loop oil. All right, it lasts quite long because the piston goes up and down, so it needs a bit of loop oil. But this loop oil is nothing special. Yeah, it does have a high viscosity, but at the end of the day, everything becomes local. Okay. But anyway, in every country, eventually we will have demo centers, and definitely we'll build up our team there. Right now, we're at the early stage where we still haven't got around to it, and we are looking for partners on that. Okay, hope that answers your question, Thomas. Sorry, any more questions?
Yeah, may I ask a question? Yeah.
Sure.
So you mentioned that in Singapore, it's possible to use the food waste.
Yes.
So you must dewater it, dry it, make it a pellet. This will consume a lot of energy.
Okay, yes, I know. The energy itself will come from the machine itself. Okay, dewatering is fundamentally mechanical, just compress it together. At 70% or even 80% moisture, when you dewater, it's a matter of compression in. We only need something like 40% moisture. We're not going to have it very dry. So one is that compression will reduce the moisture content 30–40% mechanically. And we can also have the steam or the hot air running through, which comes from the radiator fan, to actually preheat and drive the moisture content further before it's actually dried further. So from 30%, we can actually drive it down to 30%. Right. So that energy is there using the waste material. So actually there is energy anyway. We're not taking anything from the mains or anything else. Right. And obviously at the same time, once it's dried, we do not need to form that into a particular pellet. As long as it's like a bunch, it can just go in for combustion. Well, so this one can be used at every hawker center or any place also, or even a food manufacturer or community place. So that means it can be used at the hawker center to provide water for washing, cleaning, and definitely it's going to be steam. Electricity can be put and connected up to the building grid, so it will reduce the mains electricity. Okay, I see a few more questions. Is it possible to store the energy not in battery, but in potential energy by pumping water? Yes, actually, we also expect actually people to use, obviously, to store in batteries, and from where they are very poor to actually take the battery to even further away. But it's correct. You can actually pump water to a higher platform or hill and store that as potential energy that can be used. The other aspect of that, I would say, is that if the water is pumped from a river, all right, you can pump it to a pond uphill and use that water for fish rearing. And of course, you can connect hoses for it for watering the fields. That actually would enlarge the area which the farmer can use, to irrigate. Otherwise, it's going to be them praying that the rain comes. So if you do that, actually you start a complete new lifestyle for them of generating various incomes. So pump the water into a pond, which becomes a fish pond for say fish, that becomes an income source. And obviously fish, when it's slaughtered, eventually that can become, the insides can become fertilizer, which is very good. Okay.
Have you tried a product like Singapore? Of course, mainland we don't need that. Maybe but like the polar hooping,
yes,
they don't have the electricity, etc. Yeah.
Yeah, actually, Ubin will be quite a good test bed site, so to speak. Because there is obviously one wood everywhere. It would be a good demo. But before going to Ubin, we don't mind also looking into in Singapore itself. For example, one good location would be waste management companies, so collect waste. All right. They also, have electrical needs. So by doing that, they actually reduce their own electricity from the grid. But actually, a hawker center or something very useful, because then we turn the electricity and of course the steam, and steam has more value into reducing their costs from the mains. So of course everybody wants to save money.
Yes. Another question, I'm chemical engineer. I don't know this electrical, mechanical. You always, yeah. You mentioned in your presentation the power just around 5 or 4.5 kilowatts, but the rest is a heat energy. Can we adjust the ratio?
About 4 to 5 times. So roughly, we actually are quite conservative. We have 4.5 kilowatts AC, all right? In terms of the heat energy, which can be the actual radiant heat and the steam, is about 20 kilowatt, but we actually know it is more than 20. In fact, it's closer to 30. Why? We don't know. It's very simple. Well, it's very interesting to know. We know roughly it's there, but we don't have that kind of funds to look into whether it's going to be 20 or 30 or 45. That is part of another future research and development. So that is sort of like, hopefully some polytechnic, university or something will do that part. That's not our focus. Yeah, we know it's about 4 to 5 times. And right now what we get, we're actually very conservative, because if at this moment, the machine is largely uninsulated. So imagine that we actually wrap up everything and kept as hot, we would actually get 30 kilowatt without an issue.
Okay. How are you going to use the ash?
Ash, okay, ash wise, it's about 5 to 8%, 10% say maximum, but 5% is not unusual. And in this instance, I would say the ash is literally suitable for composting. Okay. And this one is quite well, because it is ash, you know, the farmers burn it in the fields. This point I'm a bit picky about, because I have seen many biodigesters, you know, and people have come to me claiming that the digestate or the compost can be used as fertilizer. Quite frankly, I doubt it, because I keep asking them for, you know, show me the proof that you're actually growing something, and so far nobody's grown it, because everybody says so, but they're more interested in selling the machine, which government has actually been giving a lot of, you know, rebate grants and so forth. All right. So I would be convinced if somebody sold a biodigester and said, this is actually the digested, and as you guys know, in biodigestion, digested is crap. Okay. It would kill the plants. So in this case, because we virtually have combustion, it's converted into ash, and that can be used as real fertilizer, compost. And you know, it's 5% is nothing.
Thank you.
Okay, I think it's a very interesting setup, maybe very useful. You know, as we mentioned, a lot of food waste are very wet. This include okara and also brewers spent grains. They have a lot of nutrition, but they can be decomposed very easily, because they have too much moisture. It's more than 80%. And if you can set up in Singapore, near the food industry, you make them like dry powder. You know, the dry powder basically it can be very valuable itself, if you can dry them. So if we want to further, process them, no matter what we do for this kind of waste, we need to dry it. You know, otherwise it's decomposed. You know. So,
yes. Actually,
so this one, because you want to use it, you need to start the machine first.
Right.
When you start the machine, you need to have some fuel to feed it, right?
Okay. Yes.
Yeah. How much fuel you need to feed it? You know, sometimes to you it's very small. To me, it's very big.
I understand.
Yeah, I think it's very big. It need a lot. It's definitely much bigger
really
than the family stove. You know, well, we also burn whatever wood for energy, for heat at home. But it's very small. But yours, actually, to me, it's very big.
I can understand that. Obviously, it's actually fairly big compared to a stove. Okay, let me explain. When we said that if you can light a fire, you can, you know, run this machine. So when you light a fire, for example, you get some newspaper and you have a bit of dry wood. That's a starting fire. Okay, so that's how it starts, and it catches on very fast. Well, one of the reasons why it catches on is because there's actually an updrive. If you have a look at the video or the slide, our air intake is below. All right, that's actually partly an air preheater, and the chimney is about 2 meters height. So there's actually an airflow going in. So there really is a natural airflow that will help in the combustion. Okay, so actually the fire, it just takes a minute for it to catch fire, and in order to build up and we feed it and it grows, it will reach full blast in 10-15 minutes, you know. So thereafter, it doesn't require anymore. We have actually run the machine and let it dry out, but there is inherent heat because the firebox itself has steel, and there is actually resident radiant heat. So if you threw in a piece of paper, even though there's not been running for half an hour, it would just burst in flames. So it's actually easy to restart it. Okay.
So are you currently still working in Singapore on this waste, kind of wood waste or okara, or are you still working on it?
No, okara is what I use in my own company, where I actually built that 1 megawatt biomass plant. I'm quite aware of it as a potential food source, all right? But as I mentioned before, for us, when you're running a business, you need volume, So while all of this is very good at the lab, 20-foot container bit, commercially, you will never make money. So you have, and this is always a problem. What is the break even that you have? How near are you? How do you convince people? And which is why industry say, no, let's make it big, because that's the only way, and you have to use mechanical, you can't do it with humans, all right? Not in Singapore, all right? It'll be too tiring. But we will eventually be looking for partners who can do all of that. And that's why, for example, we can either tie up with a waste collector, okay, or even a small farm in Lim Chu Kang or somewhere. Okay.
Yeah, so I think the urban city garbage maybe can be used, the plastic, whatever, newspaper, paper. This kind of waste can also be used as a fuel.
Okay. Yes, actually, when I showed my earlier statistic, there is a lot of paper that's still not recycled or used, and that's because in Singapore there is nobody with a factory that actually recycles paper because of our cost. So in the past, it's obviously we send a few 100,000 tons to China because there's a market for that. Now that's been cut off, then then it has to let it be burnt. So actually, paper is a fuel. And rather than look for a huge machine, then a huge plant, then let's make it small, okay? And which is what the Nexus plant is doing there. By gathering as much of the biomass or biogas materials, you have to have scale. Really in Singapore, no company by itself will take that kind of responsibility, because that becomes a public good. So why are they doing that? Okay, but in terms of making use, we believe that going small and distributing, therefore you actually bring that energy generation, waste to energy locally at your door, right at your factory. And the thing is, we have actually simplified it as much as possible, which is, like I said, easier said than done. But we will fundamentally disrupt the small scale diesel generators.
Okay, I'm just curious, if you work on, let's use the Okara, if you want to just use Okara sustainably, to use Okara as a fuel and produce Okara dry powder using your machine, is it possible? Is it sustainable?
Yes, actually.
Self-sustained?
Yes. One is that obviously Okara is a useful product by itself. What happens is that when we go through our drying process, okay, it can be through a simple air blower. That radiator you saw there was actually from trucks. All right, so you have the truck radiator. We actually use 2 of that, so it's off the shelf. But the air that comes out is about, depending how far you are, 60, 70, 80 C. That actually can be used for drying it to bring down the moisture. Not just bringing down the moisture. At the same time, actually, it sterilizes the materials. Okay, so when you bring it down, whether it's like 70, 60, 50, 40%, eventually at some stage you will need it to be so good enough that you can put it through an extruder, right? And, so you can extrude it either as small pellets or bigger briquettes of some sort. So whether it's like 30%, 20 or 10%. And if you want to go down to the powder form, then 5%. And that would have been completely sterilized.
Yeah. But then your fuel must be from Okara also,
That's okay. It can be anything.
No, I mean the energy, everything must be from the same source. So how to make it sustainable? Because if you want to dry the Okara, you use other fuel, right?
No, I think in anywhere there, if you're going Okara or something, that's going to be, biomass left behind.
Oh, okay. So extra, you have extra, right, actually?
Almost always. So you can use Okara, you can use, for example, bananas, pineapples, or anything. You can still dry bananas. You can make banana flour or tapioca.
Okay.
Definitely going to be
Good. I think we can talk about it later.
Yeah, maybe you can have more offline discussions.
Yeah,
I
yeah.
think, yeah, due
Thank
to
you.
the time constraint, we have to move on. Thank you,
Right.
Mr. Ong.
Right,
Thank you.
Bye.
Yeah.